Welcome to the deep dive. Today we're heading back, way back, to the very end of the dinosaur age in Europe.
Mm-hmm.
Our focus. It's a recently identified dinosaur genus called Blasisaurus.
That's right.
Think of this as your quick route to understanding what makes the Spanish dinosaur special. We've got the scientific description here to guide us.
Exactly. We're going to explore, how it was found, how it got its name,
Right.
what its bones actually tell us about it, and maybe most importantly, how it fits into that bigger picture of dinosaur evolution right before the end.
So if you've ever wondered about the dinosaurs hanging out in Europe just before the the big impact,
Yeah, or how paleontologists actually piece things together from, well, sometimes not much.
then you're definitely in the right place.
Absolutely.
Okay, let's jump right in with the name then. Blasisaurus. It has a nice ring to it. What's the story there?
Well, the genus name Blasisaurus, it points directly to where they found it. The Blasi 1 site in Spain.
Mm-hmm.
It's a pretty common thing, really. Naming a find after its location helps anchor it.
Makes perfect sense. Like putting a pin on the map, literally.
Exactly.
And the second part, Canoudois. That sounds specific.
It is. That part, Canudoy, is an honorific. It's recognizing Jose Ignacio Canudo.
Ah, a paleontologist.
Yep, a paleontologist who's done a lot of important work on, prehistoric life in that region and beyond. It's the researcher's way of giving a nod to his contributions.
Nice. A well-deserved nod, I imagine. So, who are the researchers? Who actually, described this dinosaur officially?
That was a team of Spanish paleontologists,
Mm-hmm.
Penelope Cruzado Caballero, Xavier Perez Suberbiola, and Jose Ignacio Ruiz Omeñaca.
Okay.
They published their findings back in 2010.
2010, so relatively recent in paleontological terms. That's when Blasisaurus officially joined the dinosaur family tree.
You got it.
And where exactly in Spain was the fossil found? You mentioned the Blasi 1 site.
Right, within the Aran Formation, the specific specimen, the main one, they based the description on the holotype.
Mm-hmm.
It's cataloged as MPZ 99667, and it's housed in Huesca.
And the age. That's pretty crucial, right?
Oh, absolutely.
Right.
The Aran Formation rocks, they date to the late Maastrichtian. So we're talking about 66 million years ago.
Wow. Okay, so right there at the very, very end of the Cretaceous period.
Exactly. One of the last dinosaurs standing, so to speak, in that part of the world.
Incredible. And what did they actually find? Was it like a full skeleton?
No, not a complete skeleton, but still a really important find.
Okay.
It was a partial skull and some fragments of the lower jaws.
Just skull and jaw bits?
Yeah, but it's actually amazing how much information scientists can pull from even fragments like that.
Yeah.
Piecing together the puzzle.
It really is like detective work, isn't it? Forensic science for ancient life.
That's a great way to put it.
Now, talking about its family, Blasisaurus is classified as a Lambeosaurine hadrosaurid. That's quite a mouthful. Can you break that down?
Sure. So Hadrosauridae, that's
Yeah.
the big family we often call the duck-billed dinosaurs.
Right, the plant eaters with the flattened snouts.
Exactly. Lots of teeth for grinding plants. Now, within that family, there are a couple of main subfamilies. One is Lambeosaurine.
Lambeosaurine.
And these guys are often the ones known for having those, well, sometimes quite elaborate, hollow crests on their heads.
Ah, the fancy headgear used for display, maybe. Or making sounds.
That's the thinking, yeah. Communication, species recognition, maybe even amplifying calls, things like that.
So being a Lambeosaurine suggests Blasisaurus might have had a crest? Do we know from the skull fragments?
Well, the fragments, they have the partial skull and jaw bits. They don't actually show a crest directly, or rule one out for that matter.
Oh, okay.
But its classification within Lambeosaurine makes it, a strong possibility. It belongs to that group known for crests. Maybe future finds will show us for sure.
Interesting. So a medium-sized plant-eating duckbill, potentially with a crest. Got it. Now, what specific features in those skull fragments really set Blasisaurus apart, made the scientists say, okay, this is something new?
Right. They identified two key unique characteristics, or autapomorphies, in the skull material.
Okay.
First, there's a bone called the cheekbone, or jugal. On Blasisaurus, the part of this bone that points towards the back of the skull, its upper edge has this distinct hook shape.
A hook shape on the cheekbone.
Yeah, specifically on that rear projection. It's a very particular shape, not seen in its close relatives.
Huh. Okay, that's pretty specific. What was the second unique feature?
The second one involves an opening in the skull behind the eye socket. It's called the lower temporal fenestra, basically a window in the bone.
Right, for jaw muscles and things.
Exactly. And in Blasisaurus, this opening is described as being narrow and distinctly D-shaped.
A D-shaped window.
Yep. The shape and size of these openings are often really diagnostic for telling different species apart. It relates to how the jaw muscles attached and worked.
So a hooky cheekbone and a D-shaped skull window. Those are the telltale signs for Blasisaurus.
Those are the main ones, yes.
Now, you mentioned close relatives. The text brings up Ouranosaurus, found in the same formation even. How is Blasisaurus different from that one?
Ah, good question. Ouranosaurus is definitely the key comparison. Blasisaurus is distinguished from it mainly by details of the teeth.
Teeth? How so?
The shape is different, and Blasisaurus' teeth lack secondary ridges, which Ouranosaurus apparently has. Subtle differences, but important.
Got it. Dental details. Any other key differences mentioned? Like with Cutalosaurus?
Yeah, there's another one called Cutalosaurus. Blasisaurus differs from it in the shape of the front of its lower jaw.
Okay.
In Blasisaurus, the very front edge of the lower jaw is kind of bent downwards more noticeably.
Right. So these small anatomical details are the clues scientists use to sort out the family tree.
Precisely. They're crucial for figuring out the evolutionary relationships, the phylogeny.
Which brings us neatly to that. Phylogeny. How did the researchers figure out where Blasisaurus fits in the grand scheme of hadrosaurs?
Well, they use a standard method called cladistic analysis.
Cladistics, okay. That involves looking at shared features.
Exactly. Shared, derived features, those unique traits we were just talking about, and others. They plug all this data into computer programs that analyze patterns of shared characteristics to build, essentially, a family tree, a branching diagram called a cladogram.
And what did the cladogram show for Blasisaurus? Where did it branch off?
The analysis pointed pretty strongly to Blasisaurus being the closest known relative to Ouranosaurus.
Ah, its neighbor from the same rocks.
Exactly, what we call its sister taxa. They're evolutionary siblings, basically.
Makes sense.
And this relationship was strong enough that the researchers actually proposed a new formal group, a tribe, called Ouranosaurine, just for Blasisaurus and Ouranosaurus.
Okay, so they get their own little subgroup, the Ouranosaurine tribe. Cool. But I think the text also mentioned there's some ongoing debate about where exactly this Ouranosaurine tribe fits within the bigger Lambeosaurine subfamily.
That's right. And that really highlights how science works. You know, it's always refining things.
Right. New data, new analyses.
Exactly. So while the Blasisaurus-Ouranosaurus link seems solid, their precise spot within the broader Lambeosaurine family tree is, well, still being debated.
What are the different ideas?
One idea, based on some analyses, places Ouranosaurine within another tribe, the Lambeosaurine proper, kind of near the base of the split between Lambeosaurine and another major group, the Parasaurolophine.
Okay, so maybe a more foundational member of that whole crested group?
Sort of, yeah. But then other studies have suggested putting Ouranosaurine actually within the Parasaurolophine group instead.
Interesting. So the jury's still out on their exact position further up the tree.
Pretty much. It depends on which characteristics you emphasize, which other dinosaurs you include in the analysis. It gets complicated. It's like piecing together a really old, messy family history.
Yeah, I can imagine. The text mentioned a specific cladogram from 2013. What did that particular diagram show? Just as an example.
Right. That cladogram is one visualization of these proposed relationships.
Oh.
It would show Blasisaurus and Ouranosaurus branching off together.
They're a Ouranosaurine tribe.
Exactly. And then it shows how that pair relates to other hadrosaurs. You'd see them placed relative to, say, more distantly related duckbills like Gryposaurus, and then closer to other lambeosaurines like maybe Syntosaurus, Amurasaurus, Parabodon, others from Europe and Asia.
So it visually maps out the proposed cousin relationships. Closer branches mean more recent common ancestors.
That's the idea. It helps you see the patterns of relatedness based on that specific analysis.
Okay, stepping back a bit then, what's the bigger picture here? Why does finding Blasisaurus in late Cretaceous Europe actually matter?
Well, it's really significant because it gives us a clearer picture of the dinosaur fauna, the types of dinosaurs that were living in Europe right up until the end. The final moments, geologically speaking.
Before the KPG extinction event.
Exactly. It shows us that even that late in the game, Europe still had its own unique dinosaur species evolving. It adds to our understanding of those final European ecosystems.
So it fills in a blank on the map for that specific time. Anything else? Any broader implications?
Yes, potentially. Studying these European hadrosaurs like Blasisaurus and Ouranosaurus, and comparing them to hadrosaurs found in, say, Asia, can give us clues about how dinosaurs might have migrated between continents back then.
Ah, using land bridges and things.
Potentially, yeah.
Yeah.
During the late Cretaceous, sea levels changed. Land bridges sometimes connected Europe, Asia, maybe even North America. If you find closely related hadrosaurs in Spain and, say, China, it suggests there might have been some movement, some connection between those areas. Blasisaurus becomes another data point in figuring out those ancient dispersal routes.
Fascinating. So it's not just a Spanish dinosaur, it's a clue in a global puzzle of dinosaur movement.
It could be, yes. It adds to that bigger story.
Okay, let's try and wrap this up then. What are the main things you think we should take away about Blasisaurus?
All right, key takeaways. Blasisaurus is a Lambeosaurine hadrosaurid, a duck-billed dinosaur from the very end of the Cretaceous, the late Maastrichtian, in Spain.
Right, about 66 million years ago.
Yep. It has unique skull features, that hook-shaped cheekbone, the D-shaped opening behind the eye that mark it as distinct. It's the closest known relative of Ouranosaurus, forming the Ouranosaurine tribe.
Though their exact spot in the bigger Lambeosaurine family is still being worked out.
Correct. And overall, its discovery enhances our picture of European dinosaur diversity just before the extinction, and potentially gives us clues about dinosaur migrations across ancient continents.
Really interesting stuff. It gives you a real sense of the constant change and evolution happening right up to the very end.
It does.
And maybe a final thought for you listening out there. Just consider this. Even as the age of dinosaurs was literally counting down its final moments, new, distinct species like Blasisaurus were still evolving, still diversifying in places like Europe.
Yeah, life finds a way, right? Even then.
Exactly.
Right.
What does that tell us about just how persistent evolution is? And maybe what other secrets are still locked away in those late Cretaceous rocks, waiting to give us more surprises about the dinosaur's final act?
Definitely food for thought.
Something to think about until our next deep dive.